to my YouTube channel. Today we want to look at the modulo arithmetic. The arithmetic, right? Plus, minus. Let's see what is going to happen in this place. How to find the real life of modulo. We use it every day. You say you know, you will see it very soon. So, let's see what I'm going to look at. We're going to look at the basic concepts, the congruence of modulo, the basic operation, and the application in our real world, in this real world, the daily life. Okay? So let's begin. What is modular? So, the modular operation is sometimes called modular operation, just like what we did before now. This means the remainder after dividing them. This is lemma. I like to give lemma. I don't like to give big grammar. No, mathematician, you don't speak too much English. So, when you divide a number by another number, what remains is called modular. Even in programming language, some of you that's experts in writing programming language, we have a code also we use for modular. We use MOD to represent making the percent. Right? We use this in programming. Okay, we are not programming. But that's why before you can source 5 in engineering or any field, we need the foundation of mathematics. Okay? So let's say we have 5 modulo 2. What is the result? This means divide 5 by 2. How many times? If you don't like, if you like, you can use this. 2, 5. How many times 2 goes here? 2. 2 times 2, 4. Minus it is what? 1. This 1 is the modulo. So you can say 5 modulo 2 is equal to 1. Is equal to 1. What of 17 modulo 5? How many times 5 goes here? 3 times. What is left? 2. What is left is 2. You can also use it this way. 17, 5. How many times it goes here? 3 times. 3 times 5, 15. Minus it, we have 2. This is the modulo. So we can do more examples. What of 20? Modulo 3. 20 modulo 3 is what? How many times it go? 6 times. That's 18. So we have 2 left. Now, what of if we have negative 3? Modulo 8. Negative 3. Modulo 8. This is very important. This is very important. What do you do? Is simplest you dot this guy from this guy. Okay? You dot this guy from this guy. What do we have? We have 5. What of 3? Modulo 11. You dot this guy from this guy. What is left is what? 8. 8. What if we have minus 11 modulo 11? The dot is what? Is 0. So you can find different kind of modules. This is very important. Okay? Are we together? Let's make it more interesting. Okay, congruence modulo. Congruence modulo, we can say two numbers are said to be congruence modulo if, listen, if let's say we have 2 modulus 4. let's say this is the same thing as 3 modulo 4. We say these guys are equivalent. This modulo, take care of this modulo. So this guy can cancel this guy. So we can not cancel, we can like factor it out. This is common, this is common. I can take one out. So this implies that 2 is equal to 3. On what? On modulo 4. Are we together? So to write this guy, we don't use equal, we use the congruent, the equivalent. That is the same. Okay? Modulo 4 is common. We choose one modulo. So we say 2 is congruence of 3. Or 2 is equivalent to 3. I hope you are with me. This is very important. So if you open this bracket, we get this back. So this will become 3 modulo 4, 2 modulo 4. Because modulo 4 is common. Are we getting? This is very important. This is just like you have 2 times 3, 3 times 3. 3 is common, right? You pick this guy, and choose one, right? Like we factor something out. Like factoring something out. 3 is common. You can say 2 plus 3 of 3. Okay? 3 is common. You choose one and you had this number. Okay? Just a layman definition. But if this modulo is not the same, you cannot say they are congruent. Okay? The modulo must be the same before you can choose one. Okay? Let's do an example to make it more clear. It's good. Now let's check the second example. What do we do here? This guy comes to this place, right? So let's do the same thing here. Minus 11. This guy come here. Minus 5. Give us what? Minus 16. Minus 16 can be pieces into 2, right? You can say minus 16 like this one. We say this is 5 times 3. Now this place we can say is 8 times minus 2. 8 times minus 2, right? This guy produces the same thing. And what we have here is 5. So we can say minus 11 is truly equivalent to 5. If and only if the modulo is what? 8. This place, the modulo is 5. This place, the modulo is 8. What about the last one? 81 minus 0 is 81. Now, how can we break this guy down? How can we break it down? Take any modulo you want, choice. So, we can write this as 27 times 3, right? If you choose 9 times 9, you get the same thing, but 9 is very big. 9 is not a prime number. Okay? So we need to look for a prime number. Like nothing we divide it again. This is very important. So we have to look for the prime number. This is a prime number, right? 2. It's a prime number because nothing can divide it. It can only divide itself and 1. The same thing here, 3 is a prime number. Remember prime number? Good. This is a prime number. So everything can be here, but the last number here should be prime number. Nothing can go again. So this is 3. So we can say truly 81 is truly equivalent to 0 if and only if the modulo is what? 27. Are we together? This is very important. This is very important. This guy must be a prime number. This guy must be a prime number. This guy must be a prime number. Okay? Let's add one more. Let's add one more. Let's say we have 25 is equivalent. Let's say it's equivalent to 5. Equivalent to 5. Is it possible? Let's check it. So let's say 25, this come here, we have minus 5, which is what? 20. We need the primary to divide this guy, and the other number can be anything. So if you use 2, it will be 2 times 10. right? If you use 5, 5 is also a prime number. So you say 4 times 5. Can we get 5? No. Can we get 5? Yes. 5 is a prime number. Nothing can go again. Okay? So, and this guy can be 2 times 2. So we can write 25 is truly equivalent to 5 if and only if the modulo is 4. Okay? This is very important. This is very important. To make life easy, let's go to the basic operation and let's see how this guy works, and also to look at the real example, the real world example of this modulo. This is very important. Okay? Let's go there. Now let's look at the basic operation. The first example says if 11 modulo of 8 is 30, 15 mod of 8 is 7. First, you find the sum of these two numbers. Sum means addition, right? So, sum. The first is 11 modulo of 8 is equal to 3. 15 modulo of 8 is 7. So, which means we have addition operation here. So, just like what we know before, addition, sum it up. 11 plus 15, this is 26. Modulo 8 is common. If the modulo is not common, you cannot operate them together. Take note of this. Just like what you find in Congress. Because in Congress, if the modulo is the same, you just choose that since the modulo is the same, it means that the number is equivalent. So the modulo must be the same for addition and subtraction. And that's multiplication. And let's go. So since it's common, we just pick only one modulo, and the result we get here is what? 10. Because 7, 3 plus 7 is 10. 3 plus 7 is 10, so which means is what? Modulo of 8. Modulo of 8. Now, if 7 plus 10 is modulo of 8, because 8 is common, now we have to reduce this guy. What is the result? 10 modulo 8 means what? Two methods we can use. The first method, we can say this guy divided by this, what is remaining? So let me show you the two methods. First one, we can use this guy. 10, 8. How many times it goes? 1. Right? 8 times 8 minus it, 2. So 2 is the answer. It means that if you don't like this method, of course, you can use minus, that is 10 minus 8 is what? Is 2. So which means, therefore, the sum of these two guys, which is 26 modulo 8, is equal to what? 2. And this is the final result. Do you understand? First condition, the modulo must be the same. If modulo is not the same, you cannot operate them together. Okay? And then, of course, 10 modulo 8 we take for the introduction, and then it is 2. Okay? Now let's solve the second question. Okay, B. Find the difference between the two modules. The difference means what? Minus, subtraction, right? So the first module is 11 modulo 8, which is equal to 3, right? Second one is 15 modulo 8, which is equal to 7. The operation here is minus. So let's minus. 11 minus 15 is what? Minus 4. Right? Modulo 8 is common. We choose one modulo. And now 3 minus 7 is what? Minus 4. Modulo of what? Of 8. Don't forget our introduction. Minus 4 modulo 8, it means minus 8 minus 4 from 8, which is what? 4. So Therefore, minus 4 modulo 8 is what? Is 4. If you stop in this place, you don't get full point because you have not really solved the problem. Okay, this is very important. Module must be this. Multiplication. See, multiplying 11 modulo 8 is 3. 15 modulo 8 is 7. Now we have multiplication operation. 11 times 15. 11 times 15. This is 5, 5, 1, 1, 165. So this is 165. The module is what? It's common, which is modulo 8. 3 times 7 is what? 21. 21 modulo 8. Now, is it final result? No. You have to do your fraction. You can use the fraction or you use minus. Let's use the both. Let's see what happens. The first one, division method, 21, 8. How many times 21 goes in 8? That should be 2, right? That should be 2. 2. Yes, 2. 2 times 8 is 16. Minus it, what do we have? 5. 5. So which means the modulo 21, modulo 8 is 5. If you don't like this method, you can use minus sign. So this will be what? 21 minus 8. That is 16. No, not 16. Borrow 1 here. 1 come here. 11. 11 minus 8. That is 13. 11 minus 8 is 13. Again, minus 8. You have to reduce this until it cannot possibly be. So 13 minus 8, it is 5. 5. You see? That is the second method. You will continue minusing until the number cannot go again, or you just divide it at once. So okay, therefore, the final result, which is 165 modulo 8, is what? Is 5. Finito. Finito. Okay? This is very important. Let me solve one example here for for multiplication. Let's say we have want to find the product of 39 times 15 modulo 11. Solution. You see, they choose only one module. This guy can be split into 2. That is 39 modulo 11. Because what? We have to find it. Times 15 modulo 11. Now, let us find it. What is 39 modulo 11? Minus or you use division. Which one you like? Quickly. Which one what? Minus. Okay, let's minus it. So we have 39 minus 11, that is 8, 2. Minus 11, that is 7, 1. Minus 11, that is 6. So, which means 39 modulo 11 is 6. You know, this place they give us. What if they did not give us? That is what we are doing. What if they did not give us? This is 6. 11 modulo 15. 15 minus 11, that is 4. Nothing can go again, right? 11 cannot go before. So it is 4. So if you operate these two together, 39, this is multiplication. 39 times 15. What did it give us? Anything give us is not that matter now. Modulo is common. So now we have pieces, this guy could be this, pieces, this guy could be this. So which means 6 times 4, 24. So 6 times 4, modulo 11. You see, well, this place they give us, but this one they did not give us. So 6 times 11, 6 times 4 is 24 modulo 11. And then how many times this guy goes here? Let's do it. 24 minus 11, that is 1. 13 minus 11, that is 2. So 24 modulo 11 is 2. So which means this guy is equal to. Do you get the point? This is very important. This place, they gave us the modulo directly. Even if you don't give us, you can find it yourself, right? 11 modulo 8 is what? 3. That is 11 minus 8 is 3. If you don't give us this one, you can find it yourself. 15 modulo 8 is what? 7. That is 15 minus 7. 15 minus 8. So if they don't give us, you can find it yourself. And that's what I did here. They did not give us here, so we have to find it ourselves, multiply it, and now we're going to do this. This is a rough work. This is a rough work. This is a rough work. Okay? Now, let's show an example on exponents of this game. Good. Now, let's show an example on exponent. How do we know that's exponent? You see? Power. Index. Okay. Now, we have to be very careful. You know, this 7, if you say it's 11 times 11 times 11 times, it's very long. So we just have to think of the way to make our life easy. As I used to say, think smart and work smart. Don't work hard. Okay, this is my theorem. Now, 11 exponent 7 modulus 13. This means that 11 times 11 times 11 times 11, 11, 11, 11. 1, 2, 3, 4, 5, 6, 7. All these guys are modulo 13. Right? You agree that this guy is equivalent, right? Good. Now let's pick one after the other. If you pick the first one, 11 modulus 11, 11 modulus 13 is still 11, right? Because this guy cannot go, right? This is smaller. Now, if you pick these two means 11 squared. And 11 squared means what? 121, right? So, what is 121 modulo 13? What is 121 modulo 13? That is, we need to find 121, how many times 13 can go, right? So, if you want, you can use subtraction method. That is 13 minus this, minus 13, minus 13, minus 13, minus 13, until you get to the lowest term. So, let's see. Let's quickly solve that one. Okay? So, 121 modulo 13. So, let's use division. 121, 13. 13 cannot go in 1, cannot go in 12. So every time it goes in 121, if we say 9, what happens? 9 times 13 times 9 is this 7, remaining 2, 2 plus 9, 11. So 9 times 13 is 117, right? 117 minus 121 minus 117 is 4, right? Good. So the modulo 121 modulo 13 is 4. If you like, you can use subtraction method. That is 121 minus 11. Answer minus 12 minus 13. After minus 13, minus 13, minus 13, minus 13, until you reduce that 13 will not go again, right? So if 11 squared is 14, this is 1, 2, 3, 4. This is 11 power of 4. I want you to think smart, right? This guy, it means that 11 power of 4 is the same thing as 11 power of 2 squared. Are we together? using index exponent. Now, the modulus of this guy is what? 4. So I can write 4 squared. You see, you have to think. Think. This guy is this guy, so I can put it inside. So I have 2 squared. So 2 squared is what? 16. Now, 16 modulus 13 is what? Let's find it. 13 16 minus 13 is what? 3. This is 3. It means that 11 power of 7 can be decomposed breakdown to 11 power of 4 times 11 power of 2 times 11 power of 1. Are we together? Because 11 is common according to this. So this becomes 4 plus 2 plus 1, which is 7. So this guy is equivalent to this guy. Now, 11 power of 4 is what? Is modulus of 3 times 11 squared is what? Modulus 4. 11 power of 1, that is 11 modulus, is still 11 times 11. All this guy is what? Modulus 13. Just find a way to break it down. Now, multiply this guy. This is what? 12 times 11. 12 times 11. So that should be 132. Modulus 13. This is bigger than this, so you have to break it down. So we can use our division. 132 by 13. 13 goes in 13. 1. So that is 30. And that is 10. So 10 times 13 is 130. It is 2. Which means, finally, 11 power of 7 modulus 13 is equal to what? 2. You see how we break it down? Just common sense. By the time you know mathematics to some level, even when you're speaking mathematically, that's the aim. Good. Let's do the last part. Division of modulus. Division of modulus. Good. Now we have what is 5 divided by 3 modulo 11. Modulo 11. Don't forget, we minus this guy from here, continuously, right? Or we divide this guy by this guy, right? So we can do the same thing here. We have 5 divided by 3 modulo 11, right? So I can say this is still as 11 minus 5 over 3, right? I minus this guy from this guy. So this will give me fraction now. So remember fraction? This is my 1, right? Find the LCM, the common factor. What this can go in and this can go in. Because it's very interesting. So 3, right? 1 can go to 3. 3 times 11, 33 minus 3 can go in 3 is 1. 1 times 5 is 5, right? So 33 minus 5, that is 27. 27 divided by 3 is what? 9. It means that 5 divided by 3 modulo 11 is equal to what? 9 under the module of 11. Good. Now, application of modular numbers in real life. In real life, we use this a lot. For example, number of days. 7 days, right? In a week, right? When you count Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, after Sunday. Okay, I think first day is Sunday, Monday, Tuesday, Thursday, Friday, Saturday, Sunday, Saturday. You stop. You start again. So that is, which means number of days is modulo 7. You count in 7. If it's hour, if it's seconds, if it's week, month, year, and so on. So the last numbers are called modulo. Okay? Now, we have an example of clock. Suppose that this is 3 o'clock. It is 3 o'clock now. Okay? And you decide that, okay, I want to be checking my phone every 5 hours. After 5 hours, I check, I leave it, I go, I come back again, another 5 hours, I check, like that. Now say, what time will it be when you check your phone the 9th time? 9 times. What we're checking every 5 hours, and this is 3 o'clock. This is common sense, right? Let's solve it 2 ways. First way, let's use elementary logic. This is clock, right? Clock starts from 12. We have 6. We have 3. We put it inside. This is 9. So obviously, this is 1, 2, 4, 5, 7, it's too close, 8, 10, and 11. This is central. Now they say it is 3 o'clock. So which means the long hand is here and then the short hand is here. It is 3 o'clock, right? Now they said I have to be checking every 4 hours. Sorry, every 5 hours. And I have to check 9 times. And let's go. It's elementary. Okay, let's count. We are here, so we count the first hour. 1, of course, can we start from here? 1, 2, 3, 4, 5. This is the first time. The second time we start 1, 2, 3, 4, 5. Second time. I go to 9 times. 1, 2, 3, 4, 5. This is third. Okay, let's use another pen. 1, 2, 3, 4, 5. This is 4 times. 1, 2, 3, 4, 5. This is 5th times. 1, 2, 3, 4, 5. This is 6 times. Let's use another pen. Start again. 1, 2, 3, 4, 5. This is 7 times. 1, 2, 3, 4, 5. This is 8 times. And the last time will be 1, 2, 3, 4, 5. So, which means 9 times. If I check 9 times, the 9th times, it will be 12 o'clock or 12. You see, it's very easy. It's very easy. Now, if you don't like this, you can use another method. So, let me say method 1. I call it layman method. Method 2. Right here. Method 2. Let me call it mathematical method. This one, we say we have 3 o'clock. We are 3 now, right? I want to check every 5 hours. 9 times. 9 times. So which means 5 hours times 9 will give us what? 45. 45. Now, normal clock is 12, right? So the modulo will be 12. So which means 45 modulus 12. When did I start? I start from 9, from 3 o'clock. So what is 45 modulus 12? What is 45 modulus 12? Let's check it. 45 minus 12 is what? This is 33. Minus 12 is what? 1. 21. Minus 12 again. That is 9. 9. 9. Minus 12 again cannot give me anything. So if it is 9, that is 9 hours. And I have how many hours? I start from 12. So 9 plus 12 give me what? 9 plus 3 give me what? 12 hours. So in 9 times I will have 12. So it's 12 hours when I will check 9 times. Do you understand? This is much logical. So you can use this one or use this one. So it's easy. This one is very fast. You don't have to read. If I say after 40 or 100 times, this will be too boring. Right? It will be too boring. So it's good to use this. So what do? The number of hours times how many times? Find the modulus of that. Of course, modulus of 12 of clock is 12, right? Yes. When you go 12, you start again. So yes is 12. So it's modulo. So if it's 100 hours, you say 5 times 100. Okay? So 100, 5 times 100, that is 500. So 500 modulus 12. The answer you get plus the time you start will give you the results. Do you understand? Let's have one more question to make it clear. Okay? Good. Now, this is another question. Well, coincidentally, we have 3 o'clock again. So, if it is 3 o'clock now, what time will it be in 89 hours? Now, this method will be very boring. You have to count 89, start from here, you have to count 89. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's boring, right? So, you can use the second method. So, we have 89. The modulus of a clock is 12, right? So, module 12. Now, we can now minus 12 until we get down, or we use division, right? We can divide 89 by 12. How many times 12 goes in 89? If you cannot think so fast, you can just use minus. But I think it's 5 times. So 12 times 5 is 5, 6, and 6, 60. Now it's more than 5. Let's use minus. 89 minus 12, that is 7. Minus 12, 5, 6. Minus 12, 3, 5. Minus 12, 1, 4. Minus 12, this is 2, 9. Minus 12, 7, 1. Minus 12, 5. So which means 89 modulo 12 is 5. So which means it's 5 o'clock. When I read it, if I start from here, I will read up to this place when I count 25. But don't forget, I start from 3, not from 12. So I have to have plus 3 hours, making it 8 hours. So which means if I start at 9, if I count 89 hours, it means that I'm going to land at 88 hours. 8 hours. If you have time, you can put 3 on it. It start from 3. 1, 2, 3, 4. I don't have to cut it. you get 800. Okay? It's very easy. Just little common sense you have to apply. You have to know the modulo you are working on before you multiply. So if today is Friday, and I tell you that, okay guys, let's meet in the next 7 days. Okay, that means this. In the next 70 days. If I say today's last class, we are not meeting until the next 70 days. How many days in a week? 7. So the modulus will be 7. So that will be 70 modulus of 7. So by the time I get it round, I will now calculate each day. Do you understand that? Do you understand that logic? So today is Friday. And I tell you that, guys, let us meet in the next 70 days. Now, for me to know which day we're going to meet after 70 days, I need to find 70 in a week. We have 7 days, right? So I need to find 70 module of 7. 70 module of 7. So 70 module of 7 is what? Okay, this one is this fraction, 77. So what we have, how many times? 10 times 70. Nothing remain. So if nothing remain, it means that the 7th day will be Friday. The 7th day, after 70 days, it will be Friday. Check it. That is what. Okay, this is very important. Let's do one more example. Okay, let's solve the last example for application. Of course, you can solve more questions. Okay, you can check our workbook and solve more questions. Okay? Don't limit yourself to what we have just solved here. Okay. If it is 4 hours now, what time was it? Was in the past. The last example was in the future, but now in the past. Was it 67 hours ago? Of course, if you want, you can use your clock. 12, 6, 9, 3, 1, 2, 4, 5, 7, 8, 10, 11. If it is 4 hours now, so counting backward, 69. You see, you have to start from here and I start counting backward. That is anti-clockwise. Anti-clockwise. It's very boring, right? You have to say 1, 2, 3, 4, 5. So you can just use the short method. What is method? We have 67. So 67 module of 12 because the highest number is 12, right? The module is 12. So what is this? Well, you can use minus type, you can use division. It's your choice. Which one you want? 67 minus 12, 5, 5. Minus 12, 3, 4. 12, 3, 1. 12, minus 12 is 1, 9. Minus 12, 7. So 64 modulus 12 is 7, which is 7 hours. So if I count from this place, anti-clockwise up till 16 hours, I'm going to land here. But where I'm going to land is up to this place. So to get this one, we have to minus 4. You have to say 4 hours minus 7 hours. So you're going to get negative of 3 hours. So the answer is going to be 3 hours backward. Okay? Very easy. So 4 minus 7, but this from here backward is 7 hours, right? So of course, minus 3, time cannot be negative, right? So if time cannot be negative, the highest time you can have is 12, and the result here is minus 3. So we have to say 12 minus 3, and that gives us 9 hours. So the answer will be 9 hours. Okay? So this is very important. This is very important. So if I start from 4 o'clock and I count backward for 49 hours, I'm going to land 9 hours because time cannot be negative, right?